In this video I'll show you how to get reverb modeling up and running for Steam Audio in Unreal Engine 4.19.2. I will cover real-time simulation as well as baking reverb, and I'll explain pros and cons of each method. Reverb is important for us humans as it provides a lot of information about the environment. It helps us estimate the size and distance of sound source and the environment as well. As structures may be built out of different materials such as wood, concrete, brick or metal, these materials will have different absorption coefficients depending on the frequency, hence they'll contribute to the frequency response of the room, also known as time energy curve or simply room sound. Steam Audio can model these properties, and let's explore how to get them running. So I've got my environment here that I've made a couple of videos back and got my two same sound sources. So basically, the first step is what we want to do is we want to locate our attenuation settings that we're using for this, and just open these up. And we can turn this one off, even though as soon as you put in reverb plugin settings over here, it completely overrides this reverb send. But anyway, so we go down to Reverb plugin settings and we find our settings. If you don't have one, you can just create a new asset just over here. Do that, click save, and then we can open these up as well and see what's inside. So simulation type real time. This means that the engine is going to compute the reverb in real time as we're walking around the map from point to point. It's going to try to compute the basically how the sound bounces off the indirect reflections and how they reach your ears. Indirect contributions essentially just controls the ratio between the indirect and direct sounds. So for now I'll just leave it for 1, and yeah, that's pretty much it. For the structures themselves, if you haven't done it from the previous video, you do need to specify the Phonon geometry component, and the material as well. So you've got a whole list of different materials that you can use, and these are all the absorption coefficients. The transmission coefficients are more for the occlusion settings, because they specify how much the sound actually goes through the walls. Scattering basically specifies how rough or smooth the surface is. So the higher the number, it goes from 0 to 1. Up to 1, that's a very, very rough material, and 0 is perfectly smooth. Before we see how it sounds, we can also, some of the settings that we can also tweak for the reverb are, if we go down to Edit, Project Settings, and then go down to Steam Audio and Indirect Sound, Real-Time Quality Settings and Baked Settings. So this bit specifies how exactly will the how the reverb is going to be rendered. So I can specify the ambisonics order, impulse duration, reverb simulation time as well, spatialization method. So the difference between the HRTF and panning is that if we do a spatialization method with HRTF, then the indirect reflections are going to be spatialized binaurally as well, hence giving you a bit more realistic result. As for the real and baked quality settings, we've got 3 presets as well as custom option as well, just to modify the needs. I'll leave the real-time ones on high for now, but essentially in terms of the bounce rays and secondary rays, the amount of bounces specifies how many times does Steam Audio compute the rays bouncing. So for example, just minimize this a little bit. So if we have a sound source over here, as a sound wave would emit from the source, it would hit this wall over here, bounce once, go over here, bounce twice, 3 times, 4 times, 5 times, 6 times, 7 times, and then up until it hits 8 times. And that's for a single ray. But for the sound source, it's going to start off with 16,000 rays, and secondary rays are going to be the ones that split off, so caused due to scattering. So essentially, it's doing a lot of ray processing. And same principle for baked settings as well. Even though the lowest for baked are it does basically more calculations for the bouncing. Hence, even the lowest baked settings are higher quality than real-time qualities than the real-time settings. All right, so let's just see. Yeah, so I've got the so this is going to be the real-time rendering demonstration. So we can hear that the engine is essentially reverbizing the fire over there. It's modeling how the rays are bouncing off this church-like structure and this wooden house over here, and also it's reflecting off the surface, off the floor as well. If we go in the house, as we're in the room, it sounds pretty good to my ear. That's kind of like what you would expect from about a room that size made out of wood. But as soon as we start moving to the side, it starts to glitch a little bit. So it cuts out quite fast at this one specific location. Let's see how the church sounds. So it kind of gives you an idea of like how of the reverb tail of this environment, but if you listen closely to the drums, it's kind of stuttering. So I presume it's struggling a little bit with the processing because it needs to like render all of this in real time. And this is a fairly complex environment because it's quite big and quite reflectant as well. If we, for example, move out here, you can hear that it's cutting out quite quickly as well. If we move over to the side, so it's kind of there, but it's not really perfect, is it? So this is mainly because we're using the real-time rendering. This could be fixed with the baked settings. For how I see it myself, the real-time rendering could be used for maybe like kind of drawing the drafts, the blueprints, and giving you like a rough idea of how the environment would sound like, which also obviously takes up a lot of processing power. But the baked settings, so they would be pre-calculated and a lot more easier for the computer to switch in between them. So let's see how we can how we can bake in the reverb. So the first thing that we need to do is go to volumes, and we need to find Phonon probe volume and just stretch it out to the size of our map. So this is basically gonna generate probes, like data points in the map where the reverb can be generated. For this demonstration, I'll do the horizontal spacing for 200. Just so the more of these dots you would have, the more accurate and the more detail you would have in your reverb. Height above floor should be about your ear height, so let's do 170. So essentially what's going to happen is Steam Audio is going to generate the reverb data at all of these single points, and then as you move across the map it's going to fade in between them. So this is going to take a bit more RAM that you kind of sacrifice for the processing power. But so the next step is, as soon as we have these probes generated, then we need to go down to our sources and we need to add a component to them that's called Phonon source. We need to give it a unique identifier, which is essentially kind of like a name. Without one, you cannot bake in the reverb. So let's do chant house, and Phonon source, and let's do for this one house drums. And then we got this over here, baking radius. So this basically specifies how many of these points within a certain radius are going to be used. For example, if our baking radius is a sphere this size, then anything outside this sphere, any probes, any data points outside the sphere are going to be ignored, and the reverb is going to only be generated up until somewhere here, which looks about right. Seems about right to me. And do the same for the other one as well, something like that. One of the ways how Steam could improve this plugin is by giving the baking radius, for example, different shapes. If we, for example, go to the church, oops, chant. So this is the bit where the shapes will be a bit more useful. Essentially for this church, I want the reverb to be only modeled up here in front of it, where there's the entrance, and obviously inside. But with this shape, in order for me to cover this front, I need to extend it so big that it also covers all of this ground, which essentially I don't need, but it still will compute all of this area as well, which is a little bit inefficient in terms of resource using. So let's just specify it like that at the moment, and I'll do the same for the other source as well. In terms of adding the phonon sources in bulk, it doesn't seem to work the same way as the geometry works with export all children if you attach these sounds to each other. So for now, I believe that you need to set these individually, just how I am doing it right now. I don't think there is a quick way around it, but I'm sure that Steam will probably implement a function how to add these phonon sources in bulk in future. And let's just extend this as well. So for example, for this one, for the beat, in order for me to cover this front, I'm even extending it out to the other house where it's completely useless. So unique and maybe custom shapes as well would be really useful for this, for the reverb baking. And we'll do the same as well for the fire. And for this one, I might make the reverb purposely small just to just just to demonstrate you guys how it kicks in better, because we're going to be able to hear the fire over here, but we won't necessarily hear the reverb because of the big attenuation. Actually, I might just move it up a back a little bit. that. Um, Another thing that I want to show you as well before we take a listen, um, in terms of specifying the material for the ground. So we've specified a material for these two structures, but we don't really have a certain material for these panels over here. So what we can do is we can go to project settings, and I believe it was Windows. No, it's going to be plugins and Steam Audio. Um, Here we can set the materials for the default BSB, default static mesh, and default landscape. So for now, I'm just going to set them all to, let's do gravel, as there's no grass. You also have the choice of doing custom materials and putting in your own values, but that basically means that you need to do a little bit of research into the different absorption coefficients and the scattering coefficients of different materials. And one more thing that I want to point out as well about the materials themselves. If we take a look at these values, so it says low frequency absorption, 0.11. It doesn't really specify what is low frequency. Well, in the manual it says that it's 400 hertz, but in this case it doesn't also specify the Q, the width of the how steep the absorption curves are. Where's the crossover point? It doesn't give us a way to modify or add in other values, for example 125 hertz or 250 hertz with the low frequencies. So I guess that would be another way of Steam improving this plugin. For example, just like maybe implementing a button over here where I can just click and click and click, just different frequencies, and set their center points and the Q values and how they overlap with each other. But anyways, so to continue this, now we actually need to bake the sound. So we've generated the probes, we've specified the phonon sources, we have the materials set for all the necessary components of the environment. I might actually just do Steam Audio. I might just set this to medium, just to make it that better. So to bake it in, we can either go to our individual sources, and we can click Phonon source and bake propagation, or we can go over here to the drop down arrow of build, click that, Steam Audio bake indirect sound. Click reverb, hold shift and click the most bottom component, and then just bake selected. And this is going to bake them in bulk. So this is going to take some time now to render out. Right, so the data is finished exporting, and now we're back into the level. So it took about a good hour to render it, only for about an environment this big and only for like 6 sources. So that kind of like maybe gives you an idea of how complex the calculations are done by the plugin. If you were to expand this maybe to bigger project, then you maybe might want to reduce the quality settings of it, or the ambisonic order for it. But let's see how it sounds anyways. So here you can see the border where the reverb starts baking in. So this is obviously without, and this is with. So this is around the place where the sphere ended. That's kind of nice, like a little reverb and fire over there. This is quite crazy. It's quite a big reverb tail. still the transition isn't that smooth. So I guess the detail could be improved by putting in more of the probe data dots. Let's see how the church sounds. So over here we can see that the plugin is trying to model flutter echo, which is a natural phenomena caused by the sound reflecting from other surfaces. Um, I would imagine it's computed this by getting the sound reflecting off of this wall, off of that inner wall, and off the ground. But I wouldn't really expect this in real life, though. So I guess the quality for this could be improved with putting in more secondary rays and more bounces. Primarily, probably more bounces, though. And let's see what happens if we put in the indirect contribution 0.5, for example. So this is gonna decrease the level of the reverb as relative to the direct sound. So that sounds a little bit more appropriate. So obviously at this point you can start playing a little bit with dials as well to see how the sound changes and maybe adjust it to your own personal taste. Overall, I think it's quite impressive knowing that this plugin is only in beta stage just now, and it being able to do such complex calculations with relative accuracy. But there's definitely room for improvement. For example, it would be interesting to find out why exactly what exactly is happening over here, because there's quite a sudden jump. Um, Other than that, thanks for watching the video. Feel free to post any questions in the comment section, and have a play with it yourself. It's quite a nice little plugin. Definitely interesting for making just some of your own projects and getting familiar with spatial sounds. In my further videos, I plan on reviewing the other one available made by Google, which is the Google Resonance. This one. Thanks.